Okay, so with the new shifter kit coming in from LMR tomorrow, what I'm going to do today is take a piece of brass material. I have a 1-inch diameter solid piece, and I'm going to make an adapter that goes from this carbon fiber shift knob that I have that usually is for an S550. I'm going to make an adapter that threads into here, and then it also will thread in to the new shifter assembly, which will have the same thread pitch as the stock shifter assembly, which is M12 by 1.75, and I have a tap here to tap those female threads so the brass piece can thread on to the new shifter piece. And then the carbon fiber shift knob is a 12mm by 1.25 thread pitch, so slightly different. And I have a you can chase some threads on the lathe in order to do that. And here's my dimensions that I laid out. So overall it's going to be just under 2 inches long, 1.962, and then you can see all the different dimensions here. And then the middle section of my piece that I'll end up with will actually mill 2 flats to bring it down to 7/8 or 0.875, so that way if it gets real tight in there, I can actually just get a wrench on the 2 flats if I need to loosen anything around later in the future. So let's get started. Okay, so I think the first step I'll do is I'll actually do the flats on both sides while it's still one solid piece and not, you know, turn down on the lathe on both sides, because later on the flat's only going to be a 1/4 inch long, wide, and that's going to be kind of difficult to grab in the mill vise later on. And I want my piece shifting on me on my last step. So let's just do the step first. So the piece is 1 inch in diameter. So what I'm going to do is I'm going to crank the 1/4 inch end mill down, and I'll actually just touch it on the face here because I'll end up facing this off on the lathe anyways. So we'll kick it on. And I'll bring it in, and I'll kind of get it centered closely. So it's going to touch it to the material to get my 0. Maybe more like a thousandth. I'll get taken off or 2. Okay, right there, a few chips came off. You can see it marked there. Okay, so I'm gonna go from the, base this off of this side will be the side that threads into the shift knob. So it's 400 plus 5/16, which is 312, which adds up to 712, but I need to get my 1/4 inch end mill on the opposite side of that. So I'll actually do 712 plus 250, which is going to come out to 962. So what I'll do is I'll lock the table from going side to side, and I'll come over here and I'll 0 out my dial here. Let me get it with 2 hands to unlock the lock. Shift it over to 0. Okay, so 0 at my dial. I will unlock the table, and the tool is up above the material, so I'll start cranking the table, and we'll roll 200, 400, 600, 800, 900, and we said 62, so 30, 40, 50, 62. All right, that looks pretty good, so I will relock the table. And what I'm gonna do is I'll kick the mill on, and I'll crank the table up with this handle so that the bottom of the end mill just starts to touch the material. And since I'm gonna do a flat on both sides, we're starting with 1 inch material, and we wanna get down to 7/8 so our 7/8 wrench can fit on the flats if we need it later on when the piece is installed. So I'm gonna take off half of both sides to bring it down to 7/8 total. So you just do 1 inch minus 7/8, you get 1/8 of an inch, or 125 thousandths. Take that in half. We're gonna take off 62.5 thousandths. We'll take off 63 just for good measure on both sides so that wrench can slip on. It's not like a real tight fit. So I'll kick the mill on. I'll start cranking the table up. And I'll try to make sure my end mill is like right in the center of my piece. Doesn't have to be perfect, just close enough. We'll call it right there. Okay, getting a few chips coming off there, so I will crank the table away like that. You can see it already left a slight flat there. So we'll actually just say it, you know, it ended up taking off a thousandth there. So instead of cranking the full 63, I'll only crank 62. And then we'll go from there. So coming over here, I have the table away from the tool. So I'll raise the table up, and then we'll feed the table back into the tool. And we'll do the full 62,000 since it's brass. And we're sitting at 73 plus 62. I could zero this out, but let's just try to do some math here real quick. 73 and 62, it's gonna be what, 133, 135? So we'll go to 0 and then to 35. Okay, there's 0, and there's 35, just like that. And always bring the handle away from the engagement point, because the weight of it could, you know, shift you up or down half a thousandths or so. Okay, so we're set up there. 73 plus 62 is 135. We're all in agreement with that, I hope. All right, now we simply will just kick the machine on. Now we'll slowly hand feed the table out, and we'll take a full 62 thousandths. Okay, so we did the top half here. So you can see our flat there. Now the tricky part is when we take the vise loose to be able to rotate this a perfect 180 and get it pointed out the bottom. So just you're gonna have to eyeball it as best you can. But before you do that, go ahead and deburr these edges here before you have it, unless you want to stick it out past the vise, and that's fine too. So I'll do that, take the other 62, and then I'll do a test fit with my 7/8 wrench to make sure it fits properly. Okay, so I got the other side done, and just as a reminder, you will have to touch the tool to get your 0 again, because when you take the material out of the vise and put it back in, you're not going to get it exactly perfect unless you based your, you know, off a marker or measurement or something. So what I did is actually just put a Sharpie mark from where about the bottom was, so that when I put the material back in, I could just look at my Sharpie mark and get it pretty much close on 6 o'clock. So that way my top flat would pretty much be opposite my bottom flat. So the thickness of my 7/8 wrench is actually a little bit more than 1/4 inch. So what I'm gonna do is just measure with the caliper, and as long as it's 875 or a hair below, I'm good to go. So I'll take it out of the vise and get a quick measurement here. Okay, we are looking at, I think we're looking at 879, or about 880, so it's actually 5 over. I actually might want to take a quick 5 thousandths off of there, just because I got close, but not quite. Okay, so now that I got my piece chucked up in the lathe, I will face it, and then I will take the first 400 and plus the 5/16, so a total of 712. I'll take that all the way down to 5/8 or 0.625 diameter, and then I'll come out to the last 400 and chase my threads. right, actually I took one face coat, so what I'll do is I'll come in, I'll touch the tool while the material's not moving until it leaves a slight mark on the face. Then I'll zero out my digital readout and I'll feed the tool over 712, or just a little bit before that. So we'll go to, I'll go to 701, or 702, give us a little 10 thousandths clearance. And then we'll finish it up there at the end. Okay, so I'll kick it on. And I'll just touch the material just so I have a basis what I'm looking at. I'll come touch the material and I'll start taking it down from 1 inch down to 0.625. Okay, so this is where I'm at now, and I will go ahead, I should be about 649 or so, so I'll check with my 0 to 1 mics, because I'm going down from 649 to 625, so I should have another 24 thousandths to go. It says 651, I'm just gonna double check. Yeah, 650 and a half, so I'll go ahead and feed in the full 25 thousandths. All right. Mic it here. And that is right on 626, so I am happy with that, because the you take the horizontal line and the 1 matches right up with it, and it's 25. It's 1 tick past 6, so 625 plus 1, 626. Okay, so next, the threaded portion is only going to be 400 thousandths long, so I'll just feed my tool in, touch the face. I'll see a mark there, then I'll zero out, and then I'll just feed the tool over 400, or about 395, and then zero it out there. And I'm going to be taking this 400 thousandth section down to the major diameter for an M12 threaded portion, which is going to be 472 thousandths of an inch. But the I measured the threaded portion inside the carbon fiber shift knob. It's actually a little bit more than that, so I'm going to take it to 475. So I don't have a sloppy fit. Alright, so it should be somewhere around 500, so I'll check it here. Since I'm only going to 475, I'm pretty close. And yep, I am at 504. So if I'm going to 504 to 475, 505 to 475 is 30, so it'll be 29. 504 to 475, so we will feed in 29. Okay. As I'm feeding this dial in, I'm moving the saddle over that way. I fed in 29 thousandths, so we'll go ahead and take that. And that's perfect. That's 475 and 474 and a half. I'm happy with that. And I'm just gonna go ahead and chamfer all my edges real quick. All right, so I have the threading tool set up here, and I have my piece turned down to 475. Now I looked up the minor diameter online, and it's 419 thousandths. So from, you know, the normal 472 to 419 is 53 thousandths. So I'll just probably end up taking 10 thousandths at a time. Now to set the machine up, the lathe up to cut 1.25, we just locate the threaded portion here on our diagram, and we're not doing standard threads, doing metric threads, and we find 1.25 here. So we're going to be on L, which I believe is just for low speed, which we are on with this dial here to match up with the L, and then we're going to go S3Y. So the C might match up with the first set of gears here with the C, so I'll just leave that alone. It's already on S for our S, and then 3 is going to be our Ferrari gated shifter looking piece. So I'm going to kick it from 8 up into the 3rd position, and then it's on V currently, and I will just kick it over to Y. And this one you may have to, you know, shift the chuck around to get this one to move here. So let me do that real quick. So actually I was incorrect. So the L actually refers to this dial over here, and it's already on the L. It could be L, neutral, or high. So you would have it on the high speed for some different threads you would cut, like for example there and there. So it's already on low, and then this right here on the saddle is the engagement. So when the machine's running, I crank this down. When it grabs on to this threaded piece, then the machine will start threading. And then this gauge right here will be spinning, and I'm just gonna, off of this little rivet here, I'm just gonna go off the, let's say the number 2 mark every single time, so I keep it consistent. So everything seems to be set up. Let me just do a little test here. So waiting for this to swing back around to 2. If I get my threaded portion, let me wait for it to go around again. Right there. So now it starts threading over. Okay, so I'm gonna have to watch this real carefully. Okay, so I'm gonna see if the shift knob threads onto that. May have to just chamfer the end there. Okay, so on my shift knob, if you look down in the hole, you can see there's like almost like a steel piece. Almost looks like a helicoil down in there. It's maybe broken off, but I was tapping for the bigger threads closer to the end of the hole. And the minor diameter is actually more like 489, so I actually had to cut my piece off to the correct length, but flip it around and do the threads on the other side, which I was not intending to do. So I just took it down to just around 500, but I should have, yeah, maybe left a little bit higher, maybe more like 520. So this is just a uncommon thread size, but maybe I got this used, so maybe brand new. That steel piece down there threads all the way up for M12 by 1.25, but the thread pitch I just did check with my thread pitch gauge, my metric one here, and a 1.25 does work. So it's a little bit of a sloppy fit, so it does thread on. You can see it's sloppy, but once you get it tight, it is no longer, it takes up. So I'm gonna run with that for now. If I need to, I can make another one, but I'm glad I figured out that this works with the threading tool. So now what I'll do is I'll chamfer off my ends here. I'll flip it around and I'll drill out with my extra, which is like a 397 thousandths of an inch, and I'll run my 12mm by 1.75 tap in for the shifter handle and be done with this piece. Alright, so here's my center drill, make a pilot hole. Alright, that's good. I'll bring this back. So I can take the center drill out. And this is my, this is my X drill. So open up the chuck a little bit more. And then I'm gonna drill in maybe 7/8 of an inch deep. And I'll mark it with a scale and Sharpie here. Pretty good. And I'll run the countersink to have a nice starting chamfer for the tap. Okay, so our tap worked successfully, so I will continue to tap the rest of the way. But this project took a left turn at first, but we got to work out in the end. So you can see the threads are in there almost all the way in. And I'll just run the tap through one more time. And then this piece, I can just polish up the outside, and then just gotta wait for the new shifter kit to come in and be able to install it.